a factoring trinomial, which is what kind of threw me off yesterday when we were looking at that crazy problem. I did figure out at the end, did I show you guys the U substitution?
We were walking out and you were like, wait.
Oh, I did get it at the end, so we can do another one later on if you guys want. But this is the actual introduction into your factoring trinomials. And what we're going to actually just have time for is probably this first one. And that's when you're factoring trinomials where the leading coefficient is just a 1. So usually they start off as, this is what they'll call it. They'll call it in the form of x squared plus bx plus c. Because they're saying there's no a value there. Okay? Sorry? So let's go ahead and get started with these. Now, I'll just give you the simplest rule, I guess, that I can give you at this point. Okay? When you factor these, you're going to get two binomials. And the two numbers that you pick, well, do you guys remember the whole FOIL bit, right? The whole FOIL business? Here's what you need to know. This number comes from the first two. That number comes from the first two values that you put into your binomial. This is going to come in from the O plus the I part. Okay, the middle term comes from taking the product of the outside and adding it to the product of the inside. And finally, the last part comes in from multiplying the two last ones. Okay, so that's how yeah, it really is FOIL. And that's what the name they've given it, but all it is really the distribution property twice. Okay, so here's what we need to do. So I need two numbers at the very front. Well, the only way to get two numbers to multiply to a squared is if you take a times a, right? That should be super easy for you. Okay. Now the two numbers on the end that I multiply have to make 20. But then you have to be careful because whatever you put there, that product plus this product needs to give me the middle part.
5 and 4.
Okay. So let's try 5 and 4. So positive 5 and a positive 4. So 5 times 4 is 20. This is 4a. This is 5a. Does 4a plus 5a give me 9a? Then we're good. There it is. It's factored. We're done. Okay? So here's what you're looking for. And here's technically the rule if you don't remember. Two numbers that multiply to that, but they're going to add up to that. So the two numbers multiply to this, and they're going to add up to this middle one. That is only if you're factoring the form of x squared plus bx plus c.
Is that all you did for 6.9?
No, we actually didn't even, we factored out common terms. But then there was one problem where they got really crazy about it. They actually went into something fancier than this, which is the next bullet point. And that really threw me off because I wasn't expecting that to be seen until next week. But simple enough here, right? Okay. Questions here from anyone? Can I change the slide? Awesome. Let me... Too much work. They actually have you sit there and plan it out. Okay, so here, again. This is in the form of ax squared, so I'm just going to go like this. X. What are two numbers that multiply to 10, but they add up or subtract to 7? Or negative 7, I should say. It's 5 and 2, right? And in order, now, here's the thing. If I left them as positives, that would give me a positive 2 and a positive 5, which is a positive 7. Is that what I'm looking for? I'm not looking for a positive 7. I'm looking for a negative 7. So how can I adjust this problem?
Negative 5 and 2?
Negative 5 and a positive 2? Well, they would both have to be negative. And that's okay because negative times a negative makes a positive. And then now I have two negative numbers that are going to definitely add up to be a negative value altogether. Okay, simple enough? All right, cool. But do you guys see how I'm doing that outside plus inside business? Please make sure you understand that because when we do the other part, that helps a lot to be able to visualize that. Okay? All right, cool. Moving on. Try this one.
So it has to be negative 5, but also add up or subtract to 3.
Correct. It shouldn't take you too long to figure out you can't do this, right? Okay. Now let me tell you why. There's two types of numbers out there. There's prime numbers and there's composite numbers, right? If you're a prime number, there's only one way to multiply to get that number. 5 is a prime number, isn't it? The only way to get to it is 5 and 1. Now, no matter what I do with 5 and 1, there's no way I'm getting to 3, is it? I can add them, I get 6. I subtract them, I get 4. Okay? So you can't do that. So there has to be some way for me to be able to check, right? Anybody know that rule? Is it factorable or not? Okay. Well, if you don't, I'm going to give you that rule. It'll probably show up again, but I'm going to do it right now. How many people remember the quadratic equation? X equals negative b plus or minus. No? Okay. I'm going to give you one piece of it right now. The square root of b squared minus 4ac. Do you guys remember that piece of it?
Yeah.
That's called the discriminant. It's called the discriminant. That's negative b and it's all over 2a. But I'm looking at this part specifically. This is called the discriminant. And to check if something is factorable, what we're going to do is we're going to plug the values in. So b squared minus 4 times a times c. b happens to be 3 here. A is a 1 and c is a negative 5. So 3 squared is 9 plus, what is that, 29? 20. Right? Now, question. Is there such a thing? Sorry, actually there is. Does the square root of 29 have a whole number for its root? No. Which means you can't factor this. Okay? And that's all I have to do. I know that there is no whole number, square root of 29, so this can't be factored. Cool? Simple enough? All right, let's move on. Remember the discriminant. Oh, what about this? It is a x squared, right, with no a value, so it needs to be pp.
Minus 6 and 1. What about the square?
What about the square over with the 6? Well, now that's a fantastic question because I want to make sure I point this out. Some people were having issues last unit. Is that square belong to the 6? No, it only belongs to the q, doesn't it? Well, that's not a problem. How did we fix this issue? Well, we just did q, right? Q times q is q squared. So, now let's do the number part of it. What two numbers multiply to 6 but give you a negative 5?
1 and 6. Negative.
Well, they do multiply to this.
Well, if you do 1 minus 6, it's negative 5. But therefore,
Do you see the dilemma there? If I did, and you could do this because I love my most favorite way of factoring is a trial and error method. Okay, I know some teachers will teach you the Xbox method, factor by grouping. I really like the trial error because I know what's going on. So in order for that to happen, I need to have a 6 and a negative 1, right? No, this would have to be negative. Okay, so the only way that I could add these up to be a negative 5p would be that scenario. I did it again, didn't I? Hiya. But do they multiply to be a positive 6x squared or 6q squared? No, so this is not going to be factorable either. The only way this could be factorable if this 6 was a negative 6. Okay? Wait, they actually did it?
We told you
I told
-3
you.
and -2.
It's not, because it's not a prime number. Okay. So what was it? Negative 3 and... good looking out, guys. All right, cool. So you guys have it then, right? You guys are good with that part then? If you guys are getting it before me. Okay, here's where it gets fancier. This is the other one. Okay, this is the other one. This is where there is an a in the front. Okay, so it's going to take a little bit more work. Now, you're still trying to factor it. First thing we're going to do is we're going to factor out a common term. We're going to factor out a common term. like we did in 6.1. And this is what we did in 6.1, Steve. Okay, they all have 3a in common, don't they? Okay, so if I take 3a from this guy, what does he have left? A squared. What does this have left? Well, that's a 4a, and that would leave me with a minus 5. So then I can factor this piece of it. And this is exactly like that one problem that took us all hour. So again, two numbers are going to multiply to negative 5, add up to a 4. It's going to be a positive 5 and a negative 1. And there you go. Questions here? So you know we're good? All right, cool. Okay, let's go. Boop, boop. All right, here's the next one. Factoring trinomials where the coefficient of the square term is not a 1. So it looks like this. So let me show you my trial and error method. What I should start off doing is figuring out all the multiples of 6. So 1 times 6, I can do 2 times 3. How else can I get 6? That's it. And then to get 10, I can go 1 times 10 or 2 times 5, right? Any other way? No? All right, cool. So what I do is I just do some mock setups here. Which of these do you want to try first for the first value? The 1, 6 or the 2, 3? The 2, 3? Doesn't even matter. So 2, 3. And what do you want to match it up with over on this side? With the 2, 5? Do you want to go 2, 5 like that? Okay, so I know the first two are going to give me 6 for a fact. I set it up that way. The last two are going to give me 10. I set it up that way. Now what I need to do is check for the middle. So the product of the outside is 10. The inside is 6. If I add them, I'm going to get 16. If I subtract them, I get 4. Is that what I'm looking for in the middle?
No.
So it's not that set. Now, before I discard it, I'm going to swap the 2 and the 5. So I'm going to put the 5 here and the 2 there. Let's see what I get here. Outside, 4. Inside, 15. If I add them, I get 19. Oh, I was looking for 19. So there it is. So that means that is a specific order that I want to do them in. It's going to be a 2K and a 5, and then a 3K with a 2. What I need to decide on right now is what the signs are going to be. And they're both negative. Because a negative times a negative gives me a positive. But when I combine them, I get a negative value, and I'm done. That's the method I like. It's called the trial and error. If anybody wants to learn any other method, like the Xbox, come after school, I'll teach it to you. Or you can search for it on YouTube.
PlayStation.
Yeah, that's what it's called. They call it Xbox method. But you're going through the same process, except it's easier for me to scratch this way than it is the other way. Sometimes Xbox is helpful, but it's nice to have many tools in the shed, okay? Any questions on what I did up here? Seems easier than what you thought it was? Awesome. Okay. All right, cool. You guys want to try this one? Now, what's really nice about these is that you're going to get through this faster because this last number is prime, which means there's only one way to get it, isn't there? Okay, so in this case, it's going to have to be 1 and 3. Those are locked in. So now what I can do is I can try out factors of 10. So do you guys want to try 110 or the 225?
110.
The 110? Where do you want to put the 1? Here or here?
There.
Here? And the 10 here? Now, that's 30 and a 1. Is there any way you're going to get in your 17? No. So do I want it that way? And that's fine. That's what the trial and error method is. So there's my 1, 3. So do you want to try 110? 5, 2. You want 5 and then 2? So 5 and 2. That's 15 and 2. That does get me to the middle. So I'm there. And it looks like they're both positive. And I'm done factoring in. Okay? Cool, cool, cool.
Can't do it. What is that 110? Yeah.
Yeah, watch that schedule.
All right, we good? Homework tonight. Actually, do you want to do that one first? What's the last one going to be? It's going to be 5 and 1 because that's prime, so it can't change. So let's see here. How do I get to 6? I can do 2, 3. I think it's going to be 2, 3. That's going to be a 3 with a 2 here. Because I'm going to get 15 and 2, right? And those subtract to 13. So I want the bigger number to be positive, that one to be negative. So this is R, and that's R. And we're done. Making sense there? Awesome. Tired? A lot of it. I'm tired of a lot of it.
Thank you.
You're welcome. All right, cool. I think we'll stop there.